do with Authenticate to deal with some of the questions, but before doing so, we have to spend a few more words about the digital image lifecycle. So what happens when you press the button on your smartphone and you take a picture? We start from the scene that we have here, this strawberry, which goes through the lens of the mobile phone through an optical filter which will remove unwanted light components, and then through this CFA pattern, which will separate different light wavelengths. So it will allow the imaging sensor, which captures only light intensity and not color, to capture a mosaic of red, green, and blue values, which will then be demosaiced by this CFA interpolation. So at this point, we have a full color image, let's say, which gets processed by the software. Now, once it was just white balancing, contrast, enhancement, and saturation, today it will encompass much, much more than this. Of course, we have teeth whitening and skin enhancement and all kind of fancy things that artificial intelligence can do. And finally, normally the image gets stored as JPEG or more modern formats. A lot of metadata get added to the image, and also a thumbnail gets added, which is a tiny version of the image which is used to show the image in a gallery without having to decode the whole file. And so this is what we have at the end of the processing, which lasts, less than a second. Then, of course, nobody today takes a picture to keep it for himself. Everybody wants to share. And so we have these additional possible steps, which are shared through some social media platform. Then perhaps somebody can take your image, modify it, and share again so that hopefully it will become viral sooner or later. And every time they do some modification, the image gets recompressed and recompressed. Even the bare sharing through the social media, when you upload an image to Facebook, let's say, the image will normally get downscaled and compressed. So all of this has a deep impact, let's say, on the image lifecycle. And finally, we are given this evidence image here, and we have to understand what happened in its life. Now, for the sake of clarity, when I will say camera original image, from now on, I mean the image as it is produced on the smartphone during capturing, let's say, at the end of the capturing process. Okay, the funny part is that all of these steps that we have seen now will leave some traces or artifacts, let's say, in the image, which can be considered both a pleasure and a pain. Meaning that when your goal is to study the processing, the life cycle, the processing life cycle of the image, then all these artifacts are an asset because we can use them to understand what happened, and we can check the consistency of these artifacts throughout the image, use them to authenticate the image, and so on. But of course, when there is some unknown artifact which impede the reading a license plate, let's say, then it means that we need to invert some of the defects that have been put here. And Amped solution face both of these problems. Okay, I think we can go with some practice now. So let me show Authenticate. This is the main interface of the software. As you can see, you have here on the top bar an evidence image loader and a reference image loader, okay, where you can load two images to compare the results of the analysis. On the left, we have the filters panel, which groups filters into different categories that you can see here. We have filters in the overview category, which allows to make a first assessment, triage of the image, let's say. The file analysis is devoted to all the information about how the image is encoded and about metadata and about traces of social media processing. The global analysis is devoted to understand whether the image has been compressed more than once, whether it has been resized, possibly or rotated as a whole, let's say. So this category is to investigate the processing life cycle of the image as a whole. Then we have local analysis, which is devoted to manipulation detection. So what we want to do here is to understand whether some part of the image has been tampered with. And you see we have many different filters for many different kind of manipulations. Then we have geometrical analysis, which is very new. It was released today and allows to check the consistency of shadows inside the image, assuming, of course, the image is taken in the proper conditions. Finally, there is the camera identification part, which I will show in today's webinar, which allows to link images to the source device, to the specific exemplar which captured the image. Okay, so let's start with the images of our case study. We are given a folder with this number of images. Of course, normally there will be much more, but we don't want to waste too much time waiting for processing. So you can see that many of these images have the standard names that mobile phones use. Some of them have the WhatsApp typical name. Let's just start by loading one of the images and running a batch file format analysis. So you can see that I clicked on this tool menu where you can access even more processing tools, okay? Some of these I will show you later. The batch file format analysis will run through all the images, collect information about their compression, their format and their compression properties, and provide a table, which allows us to make a first triage of the images. Let me hide this column here. Okay, you can see the table now. So we have the list of the images here, and we have a lot of information from simple image encoded resolution. We can see that some of the images do have a thumbnail. This is expected, as we have shown before. Some other don't have the thumbnail at all, which is rather strange for a camera original image. If we move, we can see that we have the total number of EXIF metadata, okay, which is mostly consistent for most of the images, but some of the images have no metadata at all. And then we have these two very important columns from metadata, which are the make, model, and also the software column. And this tells us that for most images, the make and model is the same. It's this Sony G3112, which is the technical name of a Sony smartphone. And there are pictures with two different software values. You can see 21 and 50 as the last number, which means that the device has been probably updated from at a certain point in time, and some pictures were taken before and some after. But the most important fact we see is that some images don't have this data at all, okay? And this is marked in red because this is a strange fact for a camera original image. And this image here has Pixlr, which is a mobile phone image editing software, which is blacklisted because Authenticate has a long list of image processing software. And so it is marked in red because it is a suspicious information. On the right, we can also see that the compression properties of the images are not the same, okay? For most images, we always have the same JPEG estimated quality. We have the same quantization table, which is a technical thing of the JPEG compression. While for some other images, we have different compression properties, and this image up here has a higher quality and a different kind of quantization table and different kind of JPEG optimization strategy. So it is very different. Now, what we can do, of course, is that we can group the images like this and export them to separate folders if we want to separate the Sony-related images from other images. Now, let's focus on the two main images of interest, which are the image of this document and the image of this garden. Let's start with the garden image. So we can load it from here, load as evidence. Okay, this image is important because it could be the proof that these persons were present in this place at that time, which is important to the investigation. Now, this is the visual inspection filter, which, as easy to guess, allows to inspect the image. When the image is a bit dark in some part, there are some simple enhancement tool here to adjust the levels and make details more visible. Very simply, okay. What we can do right from the overview category is to take a look to the file format, and you will see a summary of the main image properties here in this table. Now, the first thing I want you to notice is that this evidence image warning column is mostly empty. We only have one yellow, which means moderately significant warning that the file is big, but this is just due to the fact that we are using a smartphone with very high resolution. But most of the other data looks just fine. So we have this resolution, this is a standard aspect ratio, we have a presence of thumbnail, we have a presence of EXIF metadata, which we expect to find in a camera original image. We have the common make, model, and software metadata. And also we have compression properties which are consistent with this device. Because Authenticate has a large data set of JPEG quantization tables, which are a customizable part of the JPEG compression, which changes from a device model to another. We have a large database with more than 14,000 tables, and we were able to find that the quantization table used for this image is indeed compatible with this device. Okay, so we have no warning here. Noticeably, the acquisition and last modification date reported by EXIF metadata are also all the same, as you can see here. Okay, we can then inspect more the image. We can take a look to the structure of JPEG markers. We can take a look at the hex content of the image. We can take a look to the full list of image metadata. And here we notice something interesting. We see that this image has got GPS information, which we can use both to check the correctness, the consistency of date and time with those declared in the other metadata. And you can see that the GPS timestamp is not the same as the EXIF modified date, but this is likely due to the different time zone used by the GPS clock and the mobile phone clock, which is something which, of course, we can verify. Moreover, since we have the GPS position of the image, we can go to the Tools menu and click on Show Image Location on Google Maps, and we'll be shown where the image was taken. Okay, we can click on the satellite view and zoom in. Of course, you know, GPS is not precise to the millimeter. You have to allow some meters, but nevertheless, we can see that there is a building, there is a bell tower here. And if you compare to what we saw in the visual inspection, I would say it's definitely consistent with what we have seen on the map. Not only we can see the image has been taken in daylight, and so we can use another tool, which is the checksum position for image location and date on suncalc.org, which is a very nice website, which will show you for that specific date and time declared in the image, the position of the sun compared to the place where the picture was taken. So we see that the sun is expected to be here, and if we compare it with what we see in the image, we see that shadows are indeed in the consistent direction. Okay, so we could cross-check place and time with the external information, and it was a positive check. We can also we could also go deeper and deeper for this image, but I want first to start working on the other image of interest and compare the two. Okay, so let's move now this image as a reference, and let's now load the other image that needs to be authenticated, which is this one, this document image, which is important to the investigation because it's a proof of purchase of something that has been found in the victim's house. Okay. And so we need to understand whether this is a picture which we can build on or not. Now you can see that file format filter has already turned red, which means that there is something wrong likely with this image. And if you click on it, now you can see we have a comparison view with the evidence image part and the reference image part. And you can see that now the evidence image warning has several warnings. First of all, there is no thumbnail in this image, which is strange for a camera original image. We have an editing application as the EXIF software. And we also have some oddities in how the image is stored as JPEG, okay? So all of this is suggesting us to widen the investigation of this image because there are some suspicious properties. We also have a comparison column, which allows us to quickly spot different and similar values for the various columns. If we go to the file analysis and we take a look to the EXIF, we will also see that a lot of information has been removed. Okay, so probably this image went through a processing software which stripped away a lot of metadata. We can now close the reference image, and or probably we can keep it for the next category only. Let's start with the global analysis. This is a part which requires some knowledge of how the image generation lifecycle works. However, I will just show you something simple. You can take a look to the DCT plot of the images, and this comparison shows you, below you see the expected shape of a plot for a camera original image, and above you can see the effect that you get when an image is JPEG compressed twice, okay? So the fact that we have this comb-shaped histogram is suggesting that this image was compressed once, probably during acquisition, and then one more time, likely after it has been loaded in a program, okay? So it is a trace suggesting that something happened in the life cycle of this image. We also have this other tool called JPEG Ghost Plot, which tries to show you which could be the previous compression quality of the image. Now we see indeed that the reference image has a compression quality of 96%, while the evidence image has 100%. But if we look at the plots, they are very similar and they both have a minimum, local minimum, in 96. This is suggesting us that the image on the right was compressed once, just at this quality, but the image on the left, which now is at quality 100, was probably pre-compressed before at quality 96. So we also have some hint about which was the previous compression quality of the image. Okay, so now let's take a look to the local analysis filters. You can see they are in bold here because the results have been pre-computed, because Authenticate will cache results. So if you want to leave it processing during night, you can run a batch processing. You can configure it to run all the filters on your image of interest and come back a few hours later and everything is done and ready to be analyzed. You can see here that this filter is red. It means that there is something wrong here, and indeed, this is a forgery localization map. This is the image, this is the map. And you see that here, this tool has detected that something is definitely wrong, okay? And there is no apparent reason why it should be so, meaning that it's just a blank part of the page, which should be just like all the other one, but as a red dot here, okay, a red bubble. This is because the image was first compressed as JPEG, then it was manipulated here to conceal something likely, and then recompressed. And thanks to this double compression phenomenon, we are able to distinguish the part that have been compressed twice, which are the green one, and the part for which only the last compression traces are visible, which is the edited one. Of course, you may find similar traces also with other filters. There are lots of them. You don't have to expect to find the trace on every single filter because, of course, they are complementary. You are not, you don't have to find traces in every of them. When you find an interesting result, you can bookmark it in your project. Clicking here, you can add a comment, of course. And you can also set a warning level for the bookmark, okay? Maybe this one is evident, but not so much, so we can put it in yellow, while this other one is much more evident, so we can bookmark it and put it in red. And then we can save our project. Okay. Good. Now, I cannot, we don't have time to go through all the details of single filters. However, there are some of them which are devoted to splicing detection, some of them which are devoted to copy move detection, so to detect parts of the image that's being copy pasted inside the image itself. Now that we're happy with this project, we can go to Tools and Generate Report. You will see that we get a report with all the information that are needed for repeatability, so the date, the software version, the build number of the software. You get a table of content with all the comments that you have made for your bookmarks, and for each bookmarked result, you have the input file with the hash value, you have the filter information, a description of what it does and what each parameter do, and the value that was set. If you change the software to a different language, the report itself will go to a different language as well. And also you can see scientific references to the filters that we implemented, because our vision is justice through science. So we only implement filters that have been validated from the scientific community, by the scientific community. Okay. So we can say that we were able to find evident traces of forgery for this image, while the garden image seemed just fine. I wanted to show you also that if you load one of the WhatsApp images, we have this filter called social media identification, which will compare the image property with those of images coming from several different social media platforms. And we see in this case, it found traces of compatibility with WhatsApp, TinyPic, and Facebook. And you can see that there is also a file name analysis function, which tells us that this file name here, well, this one was easy to guess actually, is compatible with WhatsApp and not with the typical TinyPic or Facebook naming scheme. Okay. Let me now go to answer the second question, which was about which images have been captured by this specific device and which not. Okay, so to show this, I will introduce this tool with one more slide. Source camera identification is one of the most useful tools of Authenticate, and it allows you to attribute an image to the specific exemplar that captured it. It is a two-stage process. There is first a camera reference pattern creation phase. So we start from a reference camera. We take some pictures. Of course, there are rules to take good pictures if you can do that. Otherwise, you can just take pictures from the memory card. And you use this to compute this camera reference pattern, which is just an estimate of the sensor noise of the camera. You know that every camera has a sensor, and this sensor has a unique noise pattern which is due to the imperfection in the silicon buffer used to create the sensor. So two cameras produced the same day in the same place will still have different noise pattern. Now that we have this estimate, we can extract the noise from the image and measure a correlation score between the camera reference pattern and the noise in the image. And we can set a threshold, and if we are above the threshold, we will say that the evidence image is compatible with the camera. Otherwise, we will say the opposite. Now, it may seem complicated, but it's very easy to do with Authenticate. Let me show you. All you have to do is you put all the images that you gathered from the camera in a folder. Then you load one of them here. Okay. Oh, sorry, it's processing now. Once you have loaded it, you can go to the create PRNU reference pattern command to start the creation of a reference pattern. You only have to tell where the camera reference pattern should be stored and where images are located, which is guessed by the image location. And you can set a number of images to be used. Usually 50 images are enough, but of course you can use all of them. And Authenticate will automatically filter out images which are not suitable, either because they have a different EXIF maker model, or they have different resolution, or they are too much saturated maybe. Once you click OK, the camera reference pattern is created. It takes a few minutes, especially with this high resolution. So I pre-computed it and loaded it. We have it here, okay? And we can use it to test our evidence images. So we start with this one. You see that after running, we have this output table, which tells us that measure the score and the threshold. So the threshold is set to 60, which is a threshold recommended by most paper in the state of the art for this technology. And we see the observed PCE, this peak to correlation energy value, is 5,000, so much above the threshold. So in this case, we can say the compatibility is positive, reasonably. We see that we also detected that this image has been resized and rotated. So compared to the full resolution of the sensor, this image has been downscaled and rotated. Indeed, we can see it's 90 degrees rotation here. We can also run a batch analysis for all the images in the folder. We will just wait for the analysis to finish, and we will have the same information that we can see here, but in an aggregated table. Okay, let me hide this column here. Okay, so here you have the table. We can sort it by compatibility. We see that we have a lot of images in the folder which are compatible with this device. Then we have 3 images from WhatsApp which have negative compatibility. So we can likely assume that these images have been received from other users. Okay, so they've been captured with the other contact cameras and they are not compatible with this device. This image here instead is positive and strongly positive, I would say, which suggests that it has been captured by this device and then shared through WhatsApp. Okay, so it remained in the WhatsApp folder, but we can tell that this one comes from the user device while these 3 were likely received. Interestingly, we see we have one of the images which are declared to be from the same model, which is negative. And if we look at that, we find the reason why. This is a selfie picture, okay? And of course, when you use the selfie camera, it's a different sensor because it's a different camera. And so you will not find a positive compatibility because you have to create another camera reference pattern with images taken from the front camera of the device. So the output is correct in this case. Okay, I think this is all we have time to see today for Authenticate. And